All right, I honestly don't remember where we were, right? We definitely talked about constructors, right? We definitely did do that. And then we talked about the private and public, how if it's private, you can't access it. Here, let's open up IntelliJ. Maybe the state of IntelliJ might give me a good reminder of where exactly we left off. Okay, we wrote, oh no, we got this far. Who is telling me, oh, come on, we did equals and everything, didn't we? The two string? When we talked about equals? We definitely talked about equals, right? Maybe it was in lab. Maybe it was in lab. Because this is the course, and this is not the course. This is a friend. Okay, all right. I'm trying to remember. Man, why can't I remember? All right. Public, private. And remember the whole thing with private. We could make these public, but then if they're public, they can be modified from outside, right? We don't want them to be modifiable. If we want them to be accessible but not changeable, then we write those accessor methods. Before that, let's restate the public, private, we were talking about that, right? We don't have public and private in Python. We kind of do with that convention of the underscore. That means private, but it's not actually enforced. Public, private, that's another keyword that we have in Java that we don't have in Python. And similarly with final. Final is another keyword we have in Java that we don't have in Python. But again, final gives us that control. Public and private, these are keywords that give us control. So it might feel like, wow, this is verbose. It's really like Java code is very verbose, which is a common complaint people have about Java. But it's with these extra keywords that it gives us more control over how the code is used. Private, you can't access them from outside the class. Final, you can create it, but you can't modify it. Like these are keywords that have meaning. And we like that. It gives us control. It makes us like cross our T's and dot our I's, everything's set nicely. And it prevents people from using the code incorrectly, which is also a good thing. Okay. Below are the accessors, sometimes called getters, for the fields. We had 3 fields, right? First name, last name, and email. The convention here would be like get first name, get last name, get email. Now, it's not always going to be like this, but generally for your fields that you want to access, you call them get whatever. So what do they do? Well, they're very simple. They just return the first name. Return the last name, the 3 fields that we had for this class. If you don't remember, the 3 fields we had for the class were first name, last name, and email. And remember, in Java, because we have to declare the variable before we assign them, we declare them outside the constructor, in the class, but not in any method. Yeah?
So get essentially just lets you access it without being able to modify it?
Exactly. All it will ever do is return a value to you, but you have no way of changing that value. It's like if I give you the value like 17. I don't give you access to the variable that stored 17. I just give you back 17. So you have 17, but you have no way to mess with the variable that I've protected. It's private. That's the idea there. You can access the value, but you can never have access to the field, the variable associated with the instance. Am I recording? Yeah. There are times where it is possible, we are going to avoid it, but it is possible to want your classes to be mutable, changeable. And in those cases, you might write setters. These are called mutators or setters. So we have accessors, getters, mutators, and setters. That would be like, okay, you have a new value like 32 and you want to give it to me and have it assigned. Or maybe you want to change my name to Bob. So you give me Bob and then I can go modify that field. We're going to avoid doing that as per good design of our code, but it is possible that you could do that, and that's what we call these things. In that case, you might say, why not just make it public? And you're right, maybe, but I still never give you direct access to that variable. You can give me a value, but I still have control over that there. So maybe like if it's an email address, maybe, okay, you give me a new email address, But I can do some like data checks first before I modify it. Like, does this even have like an @ symbol in it? If not, I can reject it and I don't change anything. So it's kind of like I can gatekeep a bit. But in general, we're not going to be writing setters, okay? Because we want our code to be immutable. That's good design. It's not necessarily bad to have setters, but it's safer and nicer to have everything to be immutable. Okay, accessors, yeah. They're public because we want them to be accessible. What do they return? Well, whatever the types of those fields are, and then get first name, get last name, get email address. They don't have to be called get email, but generally, usually they are. That's all. In Python, to access these fields, you would just say the name of the field, like my friend dot first name, right? But that gives you direct, like raw access to that field. Java, with these things, it adds that like barrier. Cool? Cool. All right, toString in Python. Remember how like, okay, I've got some object, I want to print it out. We write that repr, because otherwise you get like class name followed by OX7F52199FX, whatever, right? There wouldn't have been an X there, but whatever. It's just some garbage, right? So we write our own repr, like there's the example there. We write our own repr. That's funny, I said 7F. That one starts with 7F. We write our own repr. We override the repr, because we get one for free, and the one we get for free does this. But it's often not that helpful, so we override it by writing our own, which kind of means ignore the one we got for free and print it out in a nice way. And whenever you didn't really have anything in mind for how you want your object to be output, we would often write it out in this style, right? Name of the class, parenthesis, fields with commas. That's usually how we would represent it, right? But sometimes if you have some object and you want to print it out, you might have some formatting in mind. Like, think of like a list, right? Imagine you had a list in Python and you print out the list. You don't see list followed by a series of fields. You see like a visual representation of what was in your list. Well, that's because that's how the repr for the list was written. But if we don't have anything specific in mind, we follow something that looks like this. Sometimes it might say like first name equals self.firstname, whatever. But something that follows that pattern, right? Well, in Java, we have the same idea. The one we get for free is something very, very, very similar to the one we see in Python, but it's the name of the class followed by some number, okay? Now, more or less, that's actually the memory address, not really, but it really, of where the object is in your computer, which, okay, cool, but how helpful is that? Well, instead, we write our own. We overwrite the toString that we get for free. Again, in Java, it's called toString instead of underscore, underscore, repr, underscore, underscore. And it must be called toString, otherwise you're not really overwriting toString. And here's how I'm doing it. Well, I'm saying it's friend followed by, what's going on here? Well, this is just the string.format thing. In Python, we have those nice F strings. Remember, where you can kind of just like inline, like insert your fields there. Unfortunately, we don't have those in Java. Everyone wants them, but we don't have them. Instead, we have something kind of similar-ish, where it's string.format, and then you've got like friend, and then you say %s, and you're like, what's that? That's like a special tag that means a string. Comma, %s, comma, %s. So this string here is expecting 3 strings, and then string.format would have like a variable length number of arguments we have here, and we just a string, a string, a string. If I put a string afloat in here, it would be unhappy. So anyways. If you like that, great. If you don't like that, it's not my problem. I didn't write it like that. Yeah.
Wait, so if like the %s means string, can you put like %, I don't know, like D for double?
There's like F for float. There is a bunch of different patterns. I don't remember them off the top of my head. Whenever I need to do it, I look them up. Yeah, I saw his hand next. Yeah, yeah. What's up?
So if you were to put ones in there that were like, well, you said %F, and you were to put a string in it, would it break the code, or would it be like?
Why don't you try it and tell me? By the way, I showed you this in Python. Very briefly, I did. By the way, and you can actually, but anyway, you could even say like f.2 or .2f, which means like to 2 decimal places. So there's actually a lot you could do here. We're not going to get into it. When you need to figure it out, you figure it out. Cool? Cool. We could have also done like the string concatenation. This would have also worked. I just did string.format instead. But I could have done like friend plus first name plus comma space last name and so on. I could have done the concatenation just like we would have in Python. But there we go. And finally, so like Python, remember how if you said like print out reference to my object, it would just call repr automatically? Same thing here. If I were to print out a friend, it would call the toString automatically. I could write a friend.toString, but whenever you print it out, it does that automatically, so whatever. And just like Python, this returns a string. It doesn't print anything out, it returns the string. However, unlike Python, where Python, you could write a repr that doesn't return a string, and then it'll just crash out later. Here, if your toString doesn't return a string, this won't compile. It'll say, your function returns a string and you're not giving me a string. So, again, another win for Java. The design of like your code enforces correctness before you even start, which is pretty cool. Equals. Now the equals one, I'm going to warn you, is going to feel like a lot, but it's really not too bad, but it is going to feel like a lot. It's definitely going to seem like it. That's for, like, it'll seem like that. So here is an example. Remember how in Python the default equals, that behaved like what we would call a sameness check. It means, do I have two reference variables referencing the exact same object? If they are, it's true. Otherwise, it's false, right? If I have two references pointing to the same cup, right? Or like same person, and it would be like, hey, you're literally the same thing. Hey, of course you're equal to yourself, right? But if I had something like this, or imagine I had a clone of you sitting right there, like this, you might be literal clones with the exact same properties, exact same first name, last name, email addresses. It would say false, because by default, you're not literally the same object. So what we do is we override the existing equals, which is the sameness check. We override it with our own. And this is what we wrote. Something like this in Python. First we check, hey, is the other even a friend object? This is equals for a friend. If I have a reference to a friend in a cup, could they possibly be equal? No, that's ridiculous. So the first thing I say is, are you even referencing the same type? If you are, we'll carry on. If not, well, just return false. You're not equal. Otherwise, go in here and do this check. Now, there's a lot going on in this one line of code, but it checks is the first name equal, is the last name equal, is the email address equal. If all of these are true, all of this is true, we return true. If any of this is false, we return false. Cool? Cool. We're going to follow the same idea in Java, but there's a couple of extra checks we're going to do in Java that arguably we should be doing in Python, but we never did it because, you know, we were still learning at that stage. So a couple of other checks that we're going to do in Java that we didn't do in Python. And we're also going to make use of some special built-in tools in Java that we didn't use in Python. I'll make them clear to you. We don't have to use these built-in tools, but we really ought to use these built-in tools. And I'll explain them when we get there. All right. So in Java, we have this public Boolean equals. It returns a Boolean. Now, to override the existing equals that we get for free, the method signature, which is this line, must be exactly the same. The fact that we see @override here, that is not important. This just is a tag for like the Java compiler. It's not really functionally important. It's just a tag in your code. That it's kind of like a comment. You can think of it as helpful to you that this tells you, oh, it overrides an existing method. But it doesn't mean anything for the code, other than the fact that it is overriding it, but it would be overriding the equals that we got for free, regardless of if @override was there. Okay? So, mind the fact, so first of all, it's public. It's an equals check. It's going to return a Boolean. It must be called equals. And interestingly, we have a reference to an object. But what is an object? Well, we have a reference called O. This is the thing I want to compare myself to, right? Because remember, I'm calling equals on some instance. So the question I have is, hey, am I equal to that thing? That's the question. But O is a reference variable of type object. All objects, all types, classes in Java follow a hierarchy, a class hierarchy. All right? You can think of it as like all squares are rectangles, but not all rectangles are squares. That's actually not a great example, but that's the idea. Okay? Right? There's like a hierarchy of like specificness, I guess. At the very top of that hierarchy exists a class called object. Okay? Everything is an object. And you are allowed to have reference variables reference anything that is like type safe. If you are a human is a subclass of object, meaning an object reference variable can reference you. However, you, the object, you know that you're a human, but the reference variable doesn't know that you're a human. As far as the object reference variable is concerned, you're just an object, right? You can do anything an object can do, but any of the human-specific things you can do, I don't know about that. I'm just an object reference. This is something that we're going to be talking about a lot more, okay? For now, I'm just giving you these ideas. This is an example of I'm kind of throwing you into the deep end, and then you're going to realize it wasn't deep at all eventually. But the first thing I say is, okay, this object. Because remember, this might be an example of like I'm a human, okay? And I'm saying, are you equal to this object? What's the object? It's a cup. No, we're not, right? So that's kind of the idea. Anyways, the first question I ask is, before anything, I check sameness. I say, now, listen. Remember how in Python, whenever you said like equals equals, it would just call the equals method? Not in Java. Equals equals on objects and dot equals, like the method equals versus the operator equals, have two different meanings in Java, which is not the case for Python. So this is a big one. Equals equals on objects checks sameness. Dot equals, the default behavior is sameness, but we overwrite that. But the equals equals operator is left alone. By the way, the equals equals operator works just as you would expect for primitive types, like, hey, does the integer 5 equal the variable a, right? That is fine. But as soon as you're dealing with objects, it's sameness. That's the idea if I have two reference variables referencing the same thing. So the first question I ask here is, hey, is O literally referencing the exact same thing as me, this? Is O in this, because this, remember, is a reference variable to me, and is this O reference variable, like, pointing at me, right? That's the question I'm asking. If it is, it's sameness. And if you ever ask the question, hey, is this thing equal to itself? Yes, it is. That's the way it is. So the first question we ask, before anything, before wasting our time digging any deeper, I say, are you literally pointing to the same thing? If you are, it's the same. No need to check deeper. Does that part make sense? If at any point you have any questions about this, ask now. If you don't, that's on you. Ask. Remember, if you have a question, chances are everybody else in the room has the exact same question. So just do everyone a favor and ask the question. Yes? The O, you mean can I call it like object flim-flam? I think so. I actually don't know. I assume so, but someone maybe could check, but I assume so. Yeah. Here. Actually, I think I can check right now. So it's overriding. Yeah, looks like it. It's still overriding. Yeah. As long as the type is the same, we're good. It seems like it. If you go try to do it and it doesn't work, well, I guess it just has to be. But I don't know offhand. That's how important it is. But if you follow the convention, just call it O and you're good to go. Okay. The next question is, okay, does O reference nothing? Remember that none keyword in Python, which was a special value that means like, oh, this is nothing. Null is what we call that in Java and in C and C++, and actually not, well, in C, C++ by convention, C#, a lot of other languages, it's null. Python's the weird one calling it none, but null. So we say, hey, is presumably, if I'm an object that exists such that you were able to say, hey, does some object equal this other object? I exist. So this would be like asking, hey, does this thing that exists equal nothing? No, that's ridiculous. Yeah.
Is it ever actually possible to ask if something that doesn't exist exists?
Well, I'm going to jump to that question, and we're going to come back to that question a little bit. But so let's say I've got course objects, okay? But check this out. A, B, C, right? So I could ask the question, S out, A dot equals. This is the method we're effectively writing. We're doing it for the friend class. Here I have it written for a course class. What's a course? It's the same thing with a different name as a friend, right? Public class course, 3 fields are strings. I've got my getters, I've got a toString, and I've got my object equals. This is what we're currently writing. We're coming back to it, but I'm kind of jumping ahead to using it. So this is how I would check if 2 courses are, the same. So does A equal B? Well, here they're all the same, so we should see, yeah. So this is using it like normally, okay? True, but if I were to do something like, hey, does A equal B? The answer is going to be false, because although they are equivalent, they are not literally the same thing. Do we see? Okay? It's very important to be aware of this. Objects, equals on objects doesn't work this way you would expect. Unless it's strings and then it's sometimes, which basically tells you, don't use it on strings. Okay, A and B, cool. All right, but let's go back to this. Now, if I ask something like, hey, does A equal A? Right? Well, obviously, we know this is obvious because I've literally like wrote the code. But remember, like there could be a lot of like reading from files and whatnot going on here. So although I've hard-coded it such that they're going to be obviously the same thing, be aware like stuff like this can happen in code, right? Now, the answer to this is true. This would be this case, right? Because A, do you equal A? Well, A is a reference variable to the exact same thing. So obviously, it's the same. Now, I could do something like this. Course C equals A. What's going on here? Yeah, I don't know why, but this particular case is also that first case. Because A and C, although A and C are 2 different reference variables, they are aliases for the exact same thing. Okay? So it's still that first case of A and C are literally referencing the exact same thing. Right? Yeah, yeah, yeah. Cool. Now, what if I say course D? Now, on this line right here, I've created a reference variable, D. As of now, it references nothing. And nothing is null. So I can ask this question. This is a valid question because, although we'll check what that says, it's a valid question because it's type safe, because as far as equals is concerned, it needs to take an object, right? And well, this is a reference to something that's an object. What's it mad about? It's just a warning saying it may not have been initialized. Let's see. I guess I can't do it. Ooh, something interesting has happened there. It can be null, though, because I can do this then. There. There. So I've created a reference variable. It references nothing. And then I say, hey, are you equal to this? No, you're not, because that's nothing. And something that exists, does not equal nothing. Yeah?
So this is the overridden version.
Yes.
And inside the course class, can you use the other equals?
You mean this one?
No, the dot equals, the one that was being overridden.
So, you know what? Hold on to that thought, and we'll see how these things cascade well, we will see how these things cascade very shortly. Okay, so if O is null, yes?
I was going to ask, like, so if you wanted to delete an instance of an object, would you just, like, reassign it to the value null?
Yeah, effectively, that's what you would do. You would effectively delete it by doing that. Now, in certain programming languages, like C++, for example, if you create an instance of something, you create a constructor, you also create a deconstructor. This is how you create the object. This is how you delete the object, meaning freeing up RAM. Now in Java, we don't need a deconstructor because Java has this thing built into it called a garbage collector. Python does too. If you ever have an object that is not referenced by something and it can never be reached again, it's as good as gone, meaning just pretend it doesn't exist. That's the idea. But in C++, there is no garbage collector. And I'm using C++ as an example, but there are other languages that work the same way. And if you don't delete it, you create what we call a memory leak. Meaning you've got memory that was allocated and never deallocated. And as far as your computer's concerned, that's important. And so if you just got a big memory leak and you have a loop run forever, you're going to run out of RAM. Because your computer thinks it's important, but it's not. So in Java, to delete something, like I could go back here and be like, okay, I want to get rid of B. All right, I could be like, there, B is null. Cool. No, B. I guess here, the D would have had to have been set to something. It's not null by default, so that's why it didn't work before. But here, I've effectively deleted B by saying, yes, it did point to something, but I immediately said you're referencing null, and well, yeah. Cool. Other questions? These questions are good. Yeah. All right, back to here. So we've covered this one, the sameness check. We've covered this one, does O even exist? Because if O doesn't exist, and I try to ask something that doesn't exist to do something, it's all going to crash, right? You get what we call a null pointer exception, right? So if I were to go here and say sout b dot get program code, right? So B did exist. I set it to null. And then I say, hey, B, which it's a reference variable of type course. So as far as the reference variable concerned, this is fine. You can ask something that references a course what your program code is, because we wrote that code in the class. But the reference variable at this stage doesn't know that the thing it's referencing doesn't actually exist. The reference variable exists, and it knows it references something, or it should be referencing something of type course, but it turns out at the end of that reference is a lot of nothing. So when I run this, it's going to crash saying, null pointer exception or something like that. Yeah, null pointer exception, meaning you asked an object that doesn't exist to do something. It's like if I ask you, raise your hand. Raise your hand. Just do it. There you go. And then I go, okay, hey, this reference variable to a student, point there. Hey, raise your hand. Java's like, there's nothing there. You can't do, that doesn't make, there's a problem. Exception, program crashes. So anyways, yeah. So by the way, it's really important that we do this check before we do this check. Because if it's null, we're not equal. If I didn't check this first and then I say, hey, oh, what's your class? Well, that would be a null pointer exception if it was null. This couldn't happen. So only after this is run and we didn't return, I know that O is a reference variable to an object that does in fact exist. If it didn't exist, it would have been null and we would return false and we're done the method. It stops, it returns. If this doesn't get called, we know O exists. So the next question I ask is, compare the classes. Basically, are they the same type? That's what this is checking. Hey, O, what's your class? Hey, this, what's your class? If they match, good. If they don't, okay. So this is saying, do they not match? If they don't match, they're not the same. Hey, human and cup. You're a cup, you're a human. You're not the same. That's what we just checked. Okay? So I can go here. This would be like me saying, A and E, right? Now I go here, and we see false, because that's tripping. So no, they're not the same thing. O does exist. It was that string, howdy, but their classes don't match. Now, finally, if I ever get to this line of code, I know that not only does the thing that O references exist, I know that the classes match. I know that O is a reference variable to something of class, in this case, course. If we're talking about what we're talking about in the lecture content, I would know it's a friend. Okay? So on this line, I know that O references an object. Well, yes, but a course. So only because, so this is the biggest jump I think we have to make right now. Only because O exists and I can confirm it is a course, because if it wasn't, we would have returned false and we wouldn't have gotten to this line. Do we agree with that? If this isn't clear, ask now. So at this stage, I know it must be a course. So what I'm going to do, because whenever I ask an object to do something, whether or not that object can do something, it's all up to the type of that object's reference variable. Whether or not an object can do something is up to the object, but whether or not, like, I can ask my code to do, let me show you what I mean. If I have, like, okay. Now, I can say a dot, and as far as like Java and IntelliJ are concerned, a, well, that's a reference variable to a course. So we can ask that thing to do whatever a course can do, right? Now, if I go though and say blah dot, you will notice the get program code, get whatever are not there. Because as far as the reference variable blah is concerned, it's an object. Now, really, the thing that blah references is a, its type is object, and it can do all those things. But as far as like Java is concerned at this stage, because the reference variable is the type that it's confident in, because it doesn't know it's an object, or it doesn't know it's a course, all it knows is that it's an object, I can't tell it to do the course-specific things. So that's kind of the state we're in right now. Now you'll notice that I can do equals and toString and get class. Well, these are ones we inherit for free, right? And we overwrote, which is kind of neat, right? I know equals exists at the top level. So I can call equals on everything, whether you implemented it or not, which is kind of neat, but that's neither here nor there right now. Anyways, so going back to this, we say, actually here, no, going back to this, what I'm saying is like, okay, I, as the programmer, am really confident that this is now a course. So I'm going to create a reference variable of type course called other. It doesn't need to be other. I just like calling it other. Right? Sometimes I call it that for this and that, but whatever. Other. And it's going to reference this object. It's going to reference the same thing that O references. But we've got a problem if I write this code. Because as far as Java is concerned, even though we as the programmer can conclude that this is in fact referencing a course object, Java wants to enforce that hierarchy. It's like the idea of a square and a rectangle. A square is a rectangle, and a rectangle is a rectangle. So we can go that way. But let's say you have a rectangle that you know is a square, right? But I'm telling you, I don't know what's a square. If you've got a reference variable for a rectangle, I can reference a square. But if I have a reference variable for a square, I can't reference something that all I know, as far as I know, is just a rectangle, because it might not really be a square. It might just be the other type of rectangle, the not square rectangle. Okay? So what this is saying right here, this is called casting. This is me saying, shut up. I know. I know that you're unhappy with doing this, Java, but trust me. This here really is a course, so you can have a course reference variable, reference that thing. That's what that means. If at this stage you're like, what? That can be the magic code to make it work. The reason is, this is a reference to an object, and as far as I know, it's an object. I have no, Java, as far as Java knows, it's an object. I don't know if it's a course. But I do. So this is saying, take a course reference variable and have it reference object. Java would be mad at this. It would say something like, you are trying to have this reference by something of type course, but it's an object, and that's not safe. But I say, shut up, trust me, I know. That's what that means. Okay? This is the weird one. It is what it is at this stage, okay? Any questions about that? I don't think it's out of the realm of possibility for this to make sense right now. But it is a little weird. I will admit that. Okay? And then finally, we're doing this. Now, you know what? First, let's ignore that bottom one for a second. What I would want to do is ask, okay, what do I want to compare? For this particular example, I have 3 fields, and we're going to call these courses equal if their fields match. So I want to check if each field is equal. How do I do that? Well, I have strings. Don't use equals equals on things that aren't primitive types. Strings aren't primitive types. So you might feel tempted, this is what I mean. You might feel tempted to be like, okay, well, this dot program code equals other dot program code. And this dot course code, and so on and so on and so on. You might feel tempted to do that, but remember, equals equals wants to check sameness. And it's probably not the case that you have, like, let's draw. Let's say program code is like 11. And then another object that I want to do the comparison, right, has a program code. And it's going to reference the string 11, right? Is that the issue? Can you see that back there? Right? So equals equals would say false, even though they're equivalent. Java's weird. It might say they're the same. It's a weird thing in Java. Just never use equals equals on strings, though. Right? It would only return true if it was really like this, right? We had the reference variable, and it just so happened they were referencing. That would be weird, though. Like, that doesn't make sense. So we don't want to do that. Instead, we use the dot equals method on the objects. We ask the object, hey, are you equal? And I know that objects have an equals method. Now, strings are built into Java, so they probably have a darn good equals method built into them. But really what I would want to say is this dot program code dot equals other dot program code. And this dot and yada, yada, yada for the three things. All right? Now, which equals is this? Because we're saying like, well, hold on, we're writing the equals right now. But we're writing an equals for what class? The course class. Or if this was the lecture content, the friend class. So we are defining what it means for friends to be equal. But down here when I call the equals, I'm asking if a program code, and the type of program code is a string. So I'm asking a string its equals. And by the way, if you ever want to know, like these built-in code, if you like control click a method and you click it, whoop. No, I control clicked the field. No, I want the method. We are in the string class, and here's the strings equals. Now, don't try to make perfect sense of all that, but that's the strings equals. We're calling a different types equals. So I'm asking the string, are you equal? And I would write this the three fields to check if they're equal, right? But you will notice that's not what I have. I have objects dot equals, and then this program code, another program code. And you might be saying, well, that's not what we have. Well, if we go into objects dot equals, it effectively is what we have, but let's take a moment and explain this. First of all, mind the fact that you're like, oh, object, that's the type of the thing that it got. No. This is type object. This is objects. Objects is full of a bunch of static methods for objects. That's all. Object is a class that you can make instances of. Objects is just a class full of a bunch of static methods, functions. Okay? This equals 1. Now the reason we're using this is because it's type safe. What I mean is, what would happen if program code was null? Nope, no. This dot program code dot equals. If program code was null, this would crash because I asked, hey, null, are you equal to something? And you can't ask something that doesn't exist to run a method. You can't do it. So this is not null safe. And if you're thinking, how could that possibly happen? How can program code ever be null? Easy. There. Now it would be set to null. That can happen. And this would cause your program to crash. But we don't really want it to crash in that situation because maybe it's reasonable that it could be null. So we call this version, and this is null safe. If we go click this objects.equals and we look at it, the first thing it checks is, okay, we got an object A and an object B. First they check sameness. Then it says, hey, is A not null? If this is false, this whole thing returns false. And now if I ever ask nothing, are you equal to something? It would say false and not crash. Where before, all we ever had was, does something that exists equal something that doesn't exist? That would say false. Now we did the other. If something that doesn't exist equals something that does exist. So this is a handy way of making this null safe. And then look. First it checks sameness. It checks if A is null. Otherwise it calls A dot equals B. It just calls the one that we were trying to use. So this is just a wrapper method to make it null safe. It's a weird one that makes perfect sense once you kind of get used to it. But the first time you see it, you're left going like, that feels like a lot. But no, it's nice. It's good. Any last questions? All right, I'll see you all later.